Good evening, students. I'm currently walking my dog, but I'm using a Bluetooth headset and a screen recording program on my phone. Just thought I'd give a bit of a attempt at talking to you about something called triglycerides. Now, triglycerides are fats and oils. It's just that an oil is a liquid at room temperature. Oi! Back! Ah! Back! Ah! Okay, now I'm not being followed by the random dog that just started coming towards me then. I don't know if I'll leave that in. So, fats are solids at room temperature and oils are liquids. And there's a couple of reasons for that. Now, I'm hoping you've watched the dispersion video about dispersion, London dispersion, van der Waals forces, all the stuff that happens with your non-polar molecules. Of course, all molecules, everything can experience dispersion forces. However, if you're a non-polar molecule and you don't have dipole-dipole hydrogen bonding or ion dipole available to you, then all that's left is dispersion forces, hence they're the weakest. See, the thing is though, when there's enough of them, they actually have a chemical effect. So when you look at a triglyceride, you actually make it out of, let's see if we can see this image better. What is copyright? No, I don't care. Take me back to that awesome picture. Visit. And the great Telstra broadband internet. This one. Alright, there, glycerol. This one. You can see it's a 3-carbon chain there, methane, ethane, propane, and it's got 3 hydroxyl groups attached to it. So its name is propan 1,2,3 triol, and it's a trialcohol basically. Now the deal with it is that as propan 1,2,3 triol and being an alcohol, you're then able to get what we call a fatty acid. So you got a C double bond O bond OH there, and some big ass carbon chains, which is represented by the I groups there. And through the process of esterification, you can bring them together and join the fatty acids onto the propan 1,2,3 triol. Because remembering that an alcohol plus an acid in the right environment yields an ester. So that's why when you look at a triglyceride, it's going to have those 3 ester bonds there. So your carboxylic acid has joined with the alcohol there, and it's a condensation reaction. So it releases a water molecule in doing so. Now, of course, there's many kinds of fats and oils. You know, some are from animals, some are from plants, and there's 2 kinds that we need to talk about, and that is saturated and unsaturated fats. Now, to cut a long story short, saturated fats are saturated with hydrogen, so you have lots and lots and lots of hydrogen on there. Unsaturated fats have very little, or they have double and triple bonds. They still have plenty of hydrogen, but yeah, just not as much. So I'll be able to go to my downloads here. Yeah, look, COVID member alert. It's from the Union. That's coconut oil there. You can see the structure there. There's a couple of different long chain fatty acids there. You've got your propan 1,2,3 triol that's now become an ester, triester, and you've got 3 long ass carbon chains hanging off to the right there. Now, of course, carbon and hydrogen is all very non-polar, so these things do dispersion. And coconut oil will commonly especially if the environment's a little bit cooler, be a solid. So if you go into the shops and you look at where the coconut oil is, if the air conditioning is up, more often than not, you'll see it as sitting as a white solid inside the jar. Whereas if it's just sitting outside on, in the sun, or just in general in a air-conditioned room, it'll be an oil. And it's a very fine line from oil to solid. And the reason being is it's just like the video says, sticky sausage, non-sticky balls. These long chain fatty acids, they're very flexible. So single covalent bonds between carbons and hydrogens, they can rotate, they can kind of bend in a way. And what that means is that these long chain fatty acids have the ability to touch each other. You see, you've got to be in proximity for there to be a secondary bonding interaction to occur. So the longer these chains are, and the more chance they have to be in proximity to each other, the more chance there is that dispersion forces will have an effect, and the more temperature it's going to require to overcome them in order to become a liquid. That's why your unsaturated, your saturated fatty acids like canola oil, i.e., no double or triple bonds, these are the ones which more often than not tend to be solids at room temperatures. So it really should be called coconut fat. I mean, it is called coconut oil. Then if we go to this one that I downloaded here, I think this is linseed oil. So let's see if I can turn it on the side. You've got a linoleic acid, because each of these fatty acids, they have a name. So we've got 3 different kinds of acids here. Stearic acid is not got anything that interesting in it, but you can see in the oleic acid and the linoleic acid, you got a couple of double bonds there. Now what these double bonds do is they kink the chains. They're a little bit more rigid than your classic single covalent bond. Now when the chain kinks, it kind of makes it difficult for those chains to pack together. If they're not as tightly packed, then they're unable to have the same amount of dispersion forces. So if they can't have so much dispersion forces, and they got less of it, and it takes less thermal energy to overcome them, and therefore they're an oil. Oh shit. So that's why when you look at something that's unsaturated, more often than not, it tends to be an oil, because it has less of an ability to do the whole Van der Waals thing, because it just doesn't pack as tightly together with the chains. You got to think about it like a book. If you have the book and all the pages are nice and flat and they lay right next to each other, then you can close the pages in the book and you can stack the book next to another book and it all sits very nicely. But if you grab that book and you scrunch up all the pages in the middle and then you try and close the book, it's not going to shut properly, is it? It's kind of like what happens with your unsaturated fatty acids. Because all the kinking in the chains, it's like scrunching up them pages in the book, and they don't pack together as nicely. So it has less Van der Waals, less ability to hold together. So yeah, key message to take away too: saturated fats don't have double or triple bonds and pack together nice and tightly and have lots of Van der Waals forces. On the other hand, unsaturated fats are the ones with double and triple bonds. They pack together not as tightly because they've got kinks in the bonds, and they will tend to be a oil at room temperature, where your saturated will tend to be a solid. And an oil is the liquid at room temperature, and a fat is a solid at room temperature. And that's how Van der Waals plays into it. It's a bit of an intro. Hope you had fun.